Then test planning has another step to it that is called test control. So the first step of the fundamental test process was test planning and test control. So we discussed some of the steps of test planning. Now let's see what test control means. So after test planning, we need to measure and control the progress. So test control is nothing but once your planning has been done, there has to be some criteria to measure and control the progress. So test control is nothing but you are basically measuring how the test progress is going on, and you are controlling the progress. Test control is an ongoing activity of comparing actual progress against the plan. So test control is an ongoing activity. It's not something which will be done once. So it's an ongoing activity, and every day test control is done. And suppose you are working in a team, and every day defect report is being prepared to see how many defects have been raised, how many are still how many are in progress, how many are fixed, how many are still need to be verified, or how many are still need to be fixed by the developer. So this is all these activities are the test control activities, that you are monitoring your defects on daily basis, or monitoring the execution, or monitoring the test execution on daily basis. Suppose there are 100 test cases to be executed, you monitor your test cases, that today how many test cases were executed, how many are still pending, how many are still need to be done in next 5 days. So all these activities that you do on daily basis is all test control activity, because you compare actual progress against the plan. Then test control reports the status of test progress, including any deviations from the actual plan. So test control also gives you a proper report if there are any deviations from the actual plan. So suppose you are doing the testing, and you were supposed to finish all your 100 test cases by end of this week, and you are just done with 80 test cases by mid of Friday, and you don't expect to complete all of them. Then test control gives the status of the progress, that by Friday we won't be able to done. So it also gives you gives you a fair bit of idea about any deviations from the actual plan. Then test control monitors the testing throughout the project. So test control is an ongoing activity, and it monitors testing throughout the project. It's not a activity that will be done in particular test level. It's done in all test level, and it's an ongoing activity in complete testing life cycle. The major tasks of test control are to measure, analyze results of reviews and testing. So the major tasks, like you track test pass and fail percentage, you track test remaining. Okay, so you measure and analyze results of reviews and testing. So in this step, you basically see how many test cases are allocated in test cycle, how many of them passed, how many of them failed, what's the percentage, how many test cases are still remaining to be executed. So this is the major you can say first task of the test control activity. Then the second thing is you monitor and document test progress, coverage, and exit criteria. So you monitor how many test cases got executed, what is the testing outcome. So you also monitor like what is the outcome of the testing, how many passed and failed, and then you also do the risk assessment of test outcome. Then the other task is provide information on testing. In test control, you provide regular test progress reports to the stakeholders. So if you are working as a test lead, you monitor the test progress, percentage of tests executed, how many of them passed, how many of them failed, where are we standing today, how many test cases are still remaining to be executed. You provide all this report on daily basis to your manager or whosoever the stakeholders are. So this is another major task of test control activity. Then you also initiate corrective action. So test control not only means that you will be just providing the progress report and what the status looks like on daily basis. The test control task, the major task in test control is also to initiate corrective action. So if something is not going right, or the test execution is not going as per plan, you need to initiate corrective actions so that you can complete whatever tasks were assigned, or whatever task you want to achieve in that cycle within the specified time frame. So corrective actions can be to spend half an hour more every day so that you can execute 5 more test cases every day, and you can achieve the backlog, or you can clear the backlog of test cases so that you can finish all 500 test cases by end of this week. Okay. So these are some of the corrective actions that you can take. You can either spend more time per day, or hire more resources, get more resources to execute the test cases so that you don't miss the deadline. So these are some of the corrective actions that needs to be taken care. So like other thing is for the corrective actions is like putting more efforts in debugging, and then prioritizing defects as well. So in the corrective actions, so suppose there are a lot of defects and defect backlog is being more and more. So you need to prioritize defects and make sure that all the highs and criticals are getting fixed and verified continuously and every day. So all these kind of activities when you are kind of missing the deadline because of defects, or because of test cases not being executed fully, needs to be corrected. And the major to initiate a corrective action is another major task of test control. Then make release decisions. So another task of test control is to make release decisions. So based on information gathered during testing, decisions are made whether you want to release the software, whether you want to continue testing, stop testing, whether you want to release the software or not. So test control also helps to make the release decisions, because since you are monitoring the progress of test and defect, how the product looks like on daily basis, you can make release decisions based on the information, the test execution information. If you have 500 test cases to be executed, and you are done with all those 500 test cases, all major defects. So suppose 500 test cases, when 500 test cases got executed, there were 80 defects found. Among 80 defects, 40 were high and critical. All those 40 were fixed. In medium and lows, only 20 defects are remaining. So you can make the release decisions based on those criteria. So if just 20 low priority defects are remaining, which don't hamper the release of software, you can decide based on those test control figures that you have got. So that's another major task of test control. Then the second step is test analysis and design. So during test analysis and design, we build test designs and test procedures. The major tasks of test analysis and design are reviewing the test basis. So test basis is nothing but any document or any system which you use to figure out any of your test scenario or test cases. So it can be, test basis can be an existing software, existing system, or any existing documentation or software requirement specification, functional specification document, something like that. So what you do in test analysis and design, you review the test basis. So suppose you have a software requirement specification document, you review SRS document and design document. Then you start designing black box test cases using the test basis. So using this document, using existing system, if the system is already there, you start designing black box tests. Then this identifies gaps and ambiguities in specification and prevents defects. So if you start reviewing test bases from initial phase itself, it helps to identify if there are any gaps in the requirements and what you want to achieve during the testing, and helps us to prevent defect, because you have already started reviewing the test basis, all the test documentation, started documenting black box test, so it figures out any loopholes in the requirements, or if the requirement is not clear or is not testable. So you clarify that initially, and it helps to prevent defect. So that's the first step in test analysis. Then you identify the test conditions. So the second step is, based on the analysis of test items and specifications, you prepare the test conditions. So test condition is nothing but anything that can be tested, any part of a system that is testable or can be tested is a sort of test condition. Then the third step is designing the tests. So you apply your test design techniques to design your tests. So like equivalence partitioning, boundary value analysis, so all different sort of test design techniques are applied to design the tests. Then you evaluate testability of the requirements and system, whether the requirements that are being gathered or the system is actually testable or not. Okay, so if a tester starts doing all this analysis thing in the beginning itself, you can figure out any loopholes or any kind of shortcomings in the requirements, whether the requirement is clear or not. So you figure out the testability of the requirement. So you evaluate testability of the requirements and the system. So make sure that all requirements are testable. So let's take an example to understand what testable means. So suppose there is a system that you are developing, and there is a performance requirement which says the system should respond quickly. That's the only one line of requirement. So if this requirement is given to any tester, you won't be able to figure out what exactly that line means. Systems should be fast. There has to be some baseline against which you will be figuring out whether how you will be figuring out the performance. So the clear requirement would be that given there are 200 users logged in an e-commerce portal simultaneously, the response time for the user should be no more than 5 seconds. That's more testable requirement. It gives a clear idea how many users will be logged on an e-commerce website and what should be the response time, what should be the performance, how fast should be the response, rather than the initial requirement which just says the system, the e-commerce website or the system should respond fast. So that's what the testability is. So you need to make sure that all requirements are testable. If there is any ambiguity in requirement, you need to make sure, you need to clarify that you can write test cases for that requirement and you can test that requirement using the real test data. Then you design the test environment. Designing test environment is very important because it's where you will be executing your test cases. So in test environment you need to figure out hardware and software required to test and any supporting tools like test management or defect management tools required while you are doing the test execution. Then third step is to test implementation and execution. Now in test implementation and execution, you take test conditions and make them into test cases. Then you build test environment where test execution needs to be done. So these are the two major steps in test implementation and execution. So in test implementation, you take test conditions, whatever test conditions you have figured out from the requirements, and you convert them into actual test cases. And then you build a test environment where you will be executing your test cases. So test implementation and execution. Test implementation and execution have the following major tasks. What are the major tasks? In test implementation, develop test cases and prioritize them. So you already have test conditions with you. You need to convert those into test cases and you need to prioritize those test cases based on the risks or whatever factors have been considered in the test planning phase. Then you apply test design techniques to develop the test cases. So there are a lot of black box test design techniques, equivalence partitioning, boundary value analysis, state transition diagram. So you need to apply those techniques for developing and designing your test cases. You need to prioritize test cases based on any risk assessment. So suppose a particular module of software is of high risk, so you need to have more number of test cases covering that module, and those test cases need to be high priority rather than any module which will be kind of used by very less number of users and is of less priority. Then you create test suites. So test suites is nothing but a logical collection of tests. So like you would be doing functional testing of some modules, so just create a functional test suite which has the test cases of certain specific module. Then you will be doing regression testing. So you figure out what test cases are ideal candidate for regression testing. So you create another test suite and add regression test cases into that suite. So you create test suites in test implementation as well, and then you create you prepare the test environment on which you will be executing your test cases. So the actual setup, the software hardware setup where you'll be performing the test execution. So the other step is the test execution. So once you have done your test implementation, then you will start test execution. So in test execution, you will be executing test cases. So you have prepared all your test cases based on test design techniques. I have the test environment. Everything is ready. Test suites are ready. Then you will start the test execution. You will take your test case, execute this the actual step, and then you will match with the expected result. Okay, so if actual meets the expected, test passes, otherwise test fails. So in test execution, you record the test execution outcome with details like environment and software version. So as soon as you execute a test case, you mention on which environment, on which software version, which browser, if that's applicable. You record all those details for the test execution. Then you also compare actual with expected result. Okay, so suppose your test case says open e-commerce login portal. So login page should open is an expected result. So if login page opens successfully, it meets the expected result. You mark it as tick, yes, it passed. Okay. In case it doesn't open, you report an incident, and then you report a defect if that incident is actually analyzed as a defect, and then that defect will be fixed, and you will verify that again once that is fixed. So during test execution, you go step by step from the actual versus expected result, and if any of the actual result doesn't match the expected, you mark it as incident and a defect, and then that gets fixed. Then you perform retest after defect is fixed to ensure that defect is corrected after fixed. Okay. So during test execution, you execute your test cases. If your test cases actual result doesn't match expected result, you log a defect. That defect is fixed by developers. Once that is fixed, you get another build, install a new build on your test environment, the test environment that you have prepared in test implementation step. You retest, you re-execute the same test case, same steps again, and verify that now whatever expected results, whatever actual result is coming is matching with the expected result, and retest passed and a defect is corrected. So these are some of the